In today's video, we are going to see some different properties of limits, like the addition property. Let's just define two different limits right here. Let's see limit as x approaches b of the function h of x, and that is equal to a number L. It means that this limit is approaching L. And we have got a second limit as x approaches the number b again, and we have, let's say, g of x, and that is just equal to a number, let's say, m. All right, so we've got our two different limits right here, and we are going to see different properties of limit. All right, so let's first see the addition property of a limit. So addition property goes like, if you have limit as x is approaching a number b of these two functions added together. All right, you got a function h of x and you got a function g of x added together. So how are you going to calculate that? So that is just simple. You are going to take out this h of x function's limit. Let's see, limit as x approaches b of h of x, and then add it with the limit of g of x, limit as x approaches b of g of x. And now we know that what they are equal to, so we are going to calculate. Now this thing right over here is just equal to L, and this thing right here is equal to M. So it means that these things are just going to be L plus M. All right. Now similar case we have in the difference of functions inside the limits, as to say limit as x approaches b, and then we got these we got the difference of these two functions, h of x minus g of x. So it's a pretty simple case. You're gonna take the first limit, the limit of first function as x approaches b of h of x, and then you gotta just take the difference with the limit of the second function as x approaches b of g of x, and that thing's again equal to similar quantities. That thing is L and that thing's approaching M, so we just are gonna take the difference of L minus M. All right, now let's see if the functions are being multiplied inside the limit. So we have limit as x approaches b of these two functions, h of x times the function g of x, and we're going to take the combined limit, and now we're going to analyze. We're going to see how these are equal to some cut. All right, so we got a product of these two functions, h of x and g of x, inside. So this follows as the limit, take out the limit of h of x, it's x approaches b of h of x, and then that thing's going to be multiplied by the limit of g of x again. All right, and this thing is just going to be equal to this thing right over here is L, and this thing is just M, so it's just going to be equal to L times M. All right, that's the multiplication property of limits. Now let's see when things are different and we just take quotients of these two things, these two functions. All right, so we have got a case as limit as x approaches b of h of x over g of x. All right, so we got a pretty simple case. You're going to take the upper limit of the function as x approaches b of h of x and divide that whole thing by limit as x approaches b of g of x. All right, again, that these two things are approaching something, so that's L and that is M, so that's just going to be L over M. Similar case applies for the powers. All right, let's see if the limit is given in terms of power, or the function is given in terms of some exponents. Let's see, limit as x approaches b of the function h of x, and that is just is raised to a power a. So that's just simple. You got to take the whole power on the limit. So that's going to be limit as x approaches b of h of x, and then whole power a. And we know that this thing right here is equal to L, so that is going to be L power a. All right. These are just simple cases we are going to analyze in our next videos and solve sum of functions using these properties. All right. See you next time.